Hello everybody, welcome to the last video in chapter 26. Now we're going to get into pH and imbalances of our blood pH. So this is just a typical pH scale. pH runs from 0, which is the most acidic, to 14, which is the most basic. And so anything below 7, which is neutral, is going to be considered acidic. Anything above 7, which is alkaline, which is alkaline, is going to be very basic. So we have acidic, basic, and then neutral. I don't know if you remember where your blood pH is, but I think I'll ask that to you guys. So I'm not going to tell you right now, but hopefully you'll remember. In a slide or so it'll show. But I do want to show you this little pH teeter-totter. So this is one mechanism of showing how pH works. So when you have a low pH, that means you have a lot of hydrogen ions. If your pH goes up, that means you're lowering the amount of hydrogen ions. So they are inversely correlated. Low pH, high hydrogen ions, high pH, low hydrogen ions, okay? And so what can change or stimulate changes in pH? So we're constantly increasing and decreasing our pH dependent on what we're putting into our body. There are a lot of things that we take in that can lower our pH, and then there are things that we take in that can also raise our pH. Examples: the more carbon dioxide in our system, the lower our pH becomes. Remember, carbon dioxide is considered acidic. Different nutrients are going to potentially lower our pH. Any type of drinks that are very acidic, think of like lemonade, that's going to lower our pH. What happens, and anything that we produce inside of our system, so think of lactic acid when we are exercising, that lowers our pH. So our kidneys respond by reabsorbing bicarbonate. Bicarbonate helps to bring our pH back up, and excreting extra or excess hydrogen ions. And so this brings our pH back to where it's supposed to be. We can also increase our pH. So increasing our pH is going to typically be associated with taking in excess alkaline substances. So an example might be if you're ingesting too many antacids. I always like to use children as an example here, because if you've ever taken Tums, which almost everybody uses Tums when they have, or in the past at least, if they've had any type of acid indigestion, heartburn. And so Tums are these colorful little pills that you chew, and oftentimes they can have yummy flavors. They can be like, you can have like a fruit breeze or whatever, or like a fruit and cream Tums. So the flavor can be enticing to young children, and then the colors, they look like candy. And so you can see antacid overdose in children very easily if they get a hold of those Tums containers. And they don't have the very strong childproof locks, which childproof locks aren't always childproof. They're more or less sometimes childproof only. Another reason that you might have an increase in pH is by vomiting. If you're vomiting a lot, you're losing a lot of the hydrochloric acid from your stomach, that can actually increase your pH. If you are eating a lot of baking soda, which sounds weird, but it's a thing that some people do, that can actually increase your pH. So again, the kidneys are going to respond by releasing bicarbonate. They don't produce any bicarbonate, and they're going to reabsorb the hydrogen ions. Our respiratory system and our urinary system are both considered buffer systems. They both help to maintain our pH. So the respiratory system is going to regulate the amount of carbonic acid in our system. So if we have a lot of carbon dioxide in our blood, we're going to produce more carbonic acid. Carbon dioxide is typically eliminated at roughly the same rate that it's produced, so we don't have an excess amount, but there are different disorders that can cause us to have more carbon dioxide. Also, different problems can alter our breathing rates. So what typically happens is when our pH is decreasing, this stimulates the brainstem, the medulla, to cause our respiratory centers to start being stimulated to breathe faster. So it increases our respiratory rate. We're blowing up more carbon dioxide, which decreases carbon dioxide, which also decreases the carbonic acid in our blood, and our pH increases. If our pH is too high, so we're in alkalosis, then the brainstem is again stimulated to slow down. And so respiratory rates slow. Carbon dioxide levels increase. That means blood carbonic acid levels increase and our pH decreases. So here is increasing respiratory rate, and here you see the decreasing respiratory rate. So our respiratory system helps in maintaining our blood pH. Our urinary system is what controls it for long term. So we have different disorders that we can see when our urinary system or our respiratory system are not functioning properly. So disturbances such as vomiting, diarrhea, diabetes, emphysema, pneumonia, damage to the brainstem, renal failure, heart failure, high altitudes even, are going to cause disturbances. And so there's two basic types of disturbances. We can have an acidosis, so blood pH below 7.35, or an alkalosis, which is blood pH above 7.45. So where is our blood pH typically? Between 7.35 and 7.45, I typically say around 7.4, right? Anything below 7.35, you're in acidosis. Anything above 7.45, you're in alkalosis. You can have respiratory or metabolic acidosis, and you can also have respiratory or metabolic alkalosis. So acids can be considered volatile. Volatile acids can be eliminated from breathing, so they're eliminated as a gas called carbon dioxide. Non-volatile acids are metabolic, and they have to be excreted by the kidneys. So disorders associated with the respiratory system are going to be associated with elimination of carbon dioxide gas. And if your respiratory system can't get rid of that CO2, then the kidneys are going to compensate. Okay? When the kidneys compensate, they compensate slower than the respiratory system. They can't work as fast. It takes them a little bit longer to work. Metabolic disorders then are going to be associated with your kidneys, and so your kidneys have to do the job, but if they're not doing the job, if they can't get rid of something, then the respiratory system has to compensate, and respiratory compensation is going to be a lot faster than metabolic compensation. But remember, the kidneys are what mainly control your pH. Respiratory helps in maintaining pH, but the kidneys are the ones that produce the long-term control. So compensation is not a correcting mechanism. It just helps to maintain your pH until whatever is wrong can be fixed. Okay? And so examples, you can have a respiratory acidosis due to excessive carbon dioxide. And in that case, the kidneys are going to have to lower the amount of acid in your system by excreting acids. In respiratory alkalosis, you have excessive reduction in carbon dioxide, and so a lot of times this is when I think about it, because respiratory alkalosis is not as common as respiratory acidosis, but think of getting or hyperventilating. When you're hyperventilating, you're blowing off a lot of carbon dioxide very fast. It can make you get lightheaded and you can actually pass out. And so again, your kidneys, if you were in respiratory alkalosis for a long period, would have to compensate. And in this case, they would have to get rid of the bicarbonate and increase the amount of acids. Metabolic acidosis then is an increase in acid in the body or a decrease in bicarbonate ions. And so typically you think of metabolic acidosis and the first thing that most people think of is diabetes mellitus and ketoacidosis. So, and that's a perfect example of a metabolic acidosis where you're producing keto acids in the body. So these are metabolic acids that our kidneys have to get rid of, but they're not able to. We have to first fix the underlying problem with the diabetes. And while we're waiting, the respiratory system has to compensate. And in this way, the respiratory system will compensate by increasing the amount of carbon dioxide it blows off. And so that's when you start breathing very fast. You're blowing off a lot of carbon dioxide. And a lot of times when someone's in ketoacidosis, the breath smells fruity. And that's because of all the glucose in their blood, all that sweet sugar. Metabolic alkalosis then is loss of metabolic acids. And so think of like severe vomiting or severe diarrhea where you're losing a lot of electrolytes, a lot of acids, a lot of stuff. And you end up being in a metabolic alkalosis. In that case, you're going to slow down your breathing, try and retain the carbon dioxide in your blood. That's the respiratory compensation. And again, metabolic alkalosis is not as common as metabolic acidosis. Acidosis tends to be more common of a problem. I'm going to be showing you this video also. I'll be making you watch this video, but you can click on it and watch it at any time. It's a great video to help you learn the different acid-base balance, how to figure those questions out, okay? And so this figure here shows different symptoms of acidosis and different symptoms of alkalosis. And we can use diagnostic blood tests to identify both acidoses and alkaloses. So I'm going to stop this video now because we are at the end, and I will be uploading these to YouTube. I'll upload them to the class and I will pull them through Edpuzzle. Have a great day. Bye.